Hello everybody. Today what I would like to do in this video is to show you some very simple codes of Java and also talk a little bit about the difference between a procedural language and an object-oriented programming language. The screen that you see on is an example of a procedural language. In a procedural programming language, our code is organized into small procedures that use and change the data. In general, you would define all the variables at the top, and then you will write the procedures, and the compiler is going to execute the lines from the top to the bottom. It is also sometimes called the top-down design. In a procedural language, you also call methods, you also call functions, but still it is sharing some of the information that you had defined at the very top. In an object-oriented language, the concept is derived from creating individual objects. Anything can be thought of as an object. Objects are all around us. We can consider trees to be a particular class of objects. So in an object-oriented language or object-oriented programming, the data and the related functions are bundled into an object. What you see on your screen are some of the terms that you would hear a lot in an object-oriented programming language. And we will define these terms as we go along. Let me show you how an object-oriented programming language would interact. This is really the basic concept of an object-oriented programming language. So these individual cubes are objects, and they would have their own name, they would have their own attributes, and they would have their own behaviors. And these objects are going to be interacting with each other through messages. So this is basically your object-oriented programming language. All the related functions and the data are bundled together into an object. Ideally, the data inside an object can only be manipulated by calling in the object's functions, and these functions are the attributes and the behaviors, which means the data is kind of locked away inside your objects, and your functions provide the means of doing something with that data. In a well-designed object-oriented system, the objects never access shared or global data. They're only permitted to the data they have or the data they're given. So that kind of takes us back to a concept that we had seen. Okay, now we had talked a little bit about the individual objects. So what are classes? A class is a term that describes a specification for a collection of objects with common properties. You will often hear the term class being associated as a blueprint, which means it is a collection of objects or a blueprint of objects with common properties. A class is a specification or a template, and it is expressed as a piece of program code which defines what goes to make up a particular sort of object. And we will look into the creation of some classes and some individual objects. So just for the definition purposes, let's define a class. A class is a collection of objects that have common properties, operations, and behaviors. What's an object? An object is an instance of a class. An object are created from a class. An object would communicate with each other and with other objects by using messages. Real objects share two characteristics. They have a state and they have a behavior. Let's define some other terms that we had seen earlier. What's an encapsulation? The ability of an object to hide its data and methods from the rest of the world is one of the fundamental principles of object-oriented programming, and that is defined as encapsulation. Now, because objects encapsulate data and implementation, the user of an object can view the object as just a black box that provides services. Instance variables and methods can be added, deleted, or changed. Now, another term that you would hear a lot would be coupling. What's a coupling? In very simple terms, the degree to which a module depends on other class is called the coupling. In a good design, you should try to minimize coupling. Classes should be self-contained units that have very low dependence on other classes, meaning that understanding the use of one class should not be related to understanding of another, and that is why we create these individual objects. They are independent, but they can interact with each other, not depend on each other. Of course, related to the concept of coupling is information hiding, which is another term that we had already defined before. Information hiding is basically hiding of the implementation in a class or a module that are most likely to change, and this protects other parts of the program from changing if the implementation is changed. Another term that you would hear is inheritance, and we will talk about these things with specific codes once we get into the other chapters, or once we get into some of the advanced concepts. Multiple classes can share some of the same characteristics, and that is one of the power of object-oriented programming. So one class can share some of the same characteristics and things that are common with one another, but they also can have certain properties that make them different. So object-oriented programming language allows classes to inherit the commonly used state and behavior from other classes. You will see that in Java, we will talk about the parent and the child relationship among classes. So inheritance is used to specialize a parent class, but creating a child class would allow that parent class attributes and some behaviors to be incorporated or to be brought forward into the child class. It's just like the same concept as inheritance. You would inherit some of the properties or some of the qualities from your parents. All right. So let's go ahead and start looking into some of the real programs. So before we end the discussion about some of these objects and classes, let's summarize some of the object-oriented concepts. Everything is an object. That's how object-oriented programming is defined. Computation is performed by objects communicating with each other, requesting that from other objects we take, or requesting that other objects perform some actions, and objects would communicate with each other by sending and receiving messages. And of course, a message is nothing but a request for action bundled with whatever arguments may be necessary to complete the task. Every object is an instance of a class. A class is simply a representation or grouping of similar objects. The class is the repository for behavior associated with an object. Remember, it's a grouping of similar objects. You will also hear the term, it's a blueprint. So all objects that are instances of the same class can perform the same actions because the class is the repository or behavior associated with an object. All right, let's go ahead and start looking at some programs.